Okay, so raise your hand if you have a Twitter account. Okay, tech people with Twitter accounts, that's not surprising. So about a year ago, Elon tweeted, if Twitter acquisition completes, company will be super focused on hardcore software engineering, design InfoSec and server hardware. Who remembers this tweet? Okay, so what's the line that got the most blowback? It's the hardcore software engineering part, right? Where many people tweeted back and asked, what does hardcore software engineering even mean, right? Tweeted back, quote tweeted, asked him. And what not many people know is the fictional tale that happened ever since that evening in May 6, 2022, up until today. So what actually happened, this is an actual fictional story. So he was sitting at home, and he was thinking to himself, what does hardcore software engineering even mean? I always tweet without thinking twice. So he was thinking, and for the past year, he just couldn't find the answer. And then about 5 minutes ago, talking about 11:35, then he finally came up with the idea, he understood what it's all about, and that's when he decided, I gotta tweet this out. So he tweeted, NDC, come to room number 8 as soon as possible. And of course, that's why we're all gathered here today, right? To hear Elon's genius idea for what hardcore software engineering really is all about. And here it is, right? So rebuilding Twitter, following clean architecture and domain-driven design. It didn't have the motorcycle, and I was like, no, it's not complete without a motorcycle. Okay, so a bit about me. So my name is Amichai. I'm a software engineer at Microsoft. I'm from Israel. I have some NuGet packages, Error and Throw, if you've heard of them. I also have some Figma community files. And within Microsoft, I author and teach some courses on clean architecture and domain-driven design. I also have a YouTube channel that I opened about a year ago. So if you enjoy the talk today, then you can check it out. Maybe you'll like that as well. But enough about me. Let's talk about what we're going to be covering today. So my motivation for this talk was, first of all, to take a non-ambitious goal. My motivation for this talk was, let's take an example-first approach to cover many of the topics of domain-driven design and clean architecture, where instead of it being theory-heavy, it's going to be example-heavy. So we'll cover a lot of the ground that has to do with the various topics, but it's all going to be anchored to examples and things that you can imagine, okay? Now you can see the story-like line on the top. It's for engagement reasons. And you can see in which part we're at based on the section that we're in. So the first part is about strategic design. So if you're not familiar with DDD, then domain-driven design is split into two main categories. The first one is strategic design, and the second one is tactical design. Strategic design is about taking a big complex domain like Twitter, for example, and breaking it up into smaller subdomains. Okay, so that's the main goal of the strategic design part. Then we have tactical design, where we zoom in on each one of those subdomains. We break it up even further into domain models. So if this doesn't mean anything yet, then don't worry, we'll dive in deeper as we go along. And finally, clean architecture. So we have all these various domains, but how do we package it in a way that's testable, swappable? We can swap around components and have the various subdomains talk to one another, okay? And in the end, we'll also look at a project structure example. So how the code base can actually look like from a folder and file perspective. And I hope that will give you the overall picture of how you can take something like Twitter, which is pretty abstract at first, and break it up all the way up until you can imagine the actual code that will sit behind it. Great, so here we are, right? Elon commanded, we arrived. We're sitting over here. I should have changed the, right? This room that isn't like this, it's like this. So we arrived over here, and Elon is, okay, let's rebuild Twitter, right? Now, we need to ask ourselves, what is Twitter? What is Twitter? Is it the timeline that we're scrolling and that's Twitter? Is it the DMs? Is it the lists or topics? Or there's so many features that have to do with Twitter that Twitter isn't a small to-do list or a shopping cart where it's very easy to model it and we don't need to really split it up into various subdomains. But we're talking about a complex domain that we need to approach it in a different way, right? Luckily, Elon is here to save us. So he heard we're designing a complex system, and this is a great use case for domain-driven design, okay? So what we want to do in domain-driven design is or what domain-driven design is an approach for designing systems in a way that you can break it up into smaller components, have well-defined interactions between them. And let's look at an example. So thanks, Elon. He's giving us the first step for hardcore domain-driven design. So step number one is strategic design. Like we said, this is where we want to take a big domain and break it up into smaller subdomains with well-defined interactions between them. So over here, we can see that we have integration. The lines represent integration between these two components. So if subdomains or whatever doesn't mean anything to you yet, then you can simply imagine it as subcomponents, okay? Like logical subcomponents. So we have the search and the tweets subdomains that have an interaction between them, and we see that there's some relationship where the tweets is the upstream and the search is the downstream. And we have the social graph and the search, which doesn't have any definition for the interaction between them, right? Now, this is just an example, doesn't mean anything. What we want to do as part of strategic design is to go from the left to the right. Okay? That's the point of the entire first section. How do we do it, right? So I want to encourage you to actually imagine that we're here, Elon came in, we're all in tech. We want to break it down. Where do we start, right? What's the first step? So for this, what we can use is event storming. Event storming was invented by Alberto. And there are three main types of event storming. So the first one is big picture event storming. This is where we want to take a big, or a problem space in general, and break it down, have a shared boundaries within the problem space that we're trying to model, and to have the priorities, what's more important, where do we want to put most of our effort, have the various experts from various fields all aligning on a shared understanding. So that's big picture. Then there's process modeling, where the scope is smaller, so we choose a specific frame, and we'll look into it in a few minutes, but we choose a specific frame in which it's the process that we want to model, and it's how we go from point A to point B in a more detailed way. And finally, software design. So the output, this is for modeling what the software will actually look like. So we won't go too deep into that, but that's the last one. Okay, so big picture event storming. Who do we want in the room? Like we said, we're exploring the problem space. So we want all the relevant experts in the various fields of the problem that we're trying to solve. So because we're rebuilding Twitter following clean architecture and domain-driven design, then of course the person we want in the room is the CEO, right? We want the various decision makers from the various fields that are in the problem space. So of course we want the CEO, but we also want the CTO, right? The CTO should also probably be there to give us a technology point of view. And sales, right? Perhaps now we're changing some features, so we want the customers to know about the new features that exist. Legal, right? GDPR, whatever, things that may not be okay from a legal standpoint that we need to make sure. Public relations, maybe we want to announce on podcasts and social media about the redesign of Twitter, right? Great press. Engineers, perhaps the head engineer of the advertisement, subgroup, that could give insight insight about specific things that have to do with that. And stakeholders, basically what we want is all the decision makers in the problem space that we're solving. So I work at Microsoft, not if I do a big picture event storming session, Satya probably won't arrive, okay? So it depends on the problem space that you're trying to solve. So we start with sticky notes. Who's familiar with event storming? Or somewhat familiar with event storming? Okay, great. So about half, I'd say. So it's all about sticky notes. For a big picture event storming session, there are 5 types.
7 upcoming events.
That's not what I... So in big picture event storming, there are 5 types of sticky notes. And what I want us to do, we're not going to dive too deep into this for time constraints. You will have in the end a QR code that you can scan and you'll have the presentation. So you'll be able to zoom in and look at this in detail. I will zoom in on specific parts in a minute. But what I do want to show you is how you can use event storming or big picture event storming to find the various boundaries that we have within our system. Okay, so this is the final artifact. There are steps to how you get over here, which I'm not going to cover as part of this talk. But what I do want you to notice right off the bat is that it's in chronological order, right? So from left to right. And there are vertical lines across the board or the modeling surface These are called temporal milestones. So these are specific points in time that we say, this is the 6-month mark. Now, it makes sense that this helps us align between all the various decision makers in the room. We know by 6 months, this is what we want to accomplish, right? We want to announce the redesign on social media, for example. And then we can work our way back, right? It gives us a shared understanding of what's happening. Next, I want you to notice, so I'll go slide back. You can see the little lines that are splitting the board horizontally. These are what's called swim lanes. So as we work on our modeling surface, then we start saying, okay, wait. These two things are happening in parallel, right? So while we're announcing the redesign on social media, in the same time, the engineers are starting the initial testing of the APIs, right? And maybe the content team is starting to update the documentation towards the final release, right? Makes sense. So this is to split the space horizontally. And you can also imagine how it starts putting clear boundaries where we say, okay, advertisement has nothing to do with whatever, a different subdomain. These can be separate, right? So we can start seeing the relationships that we have between the various components. So I want to show you that, like some of the sticky notes, because it will be relevant for later. So in orange, we have domain events or events. These are interesting things that happened from a business point of view within our system. They're defined in past tense, and each domain event has an actor who initiated the domain event or that eventually made the event to happen. So it could be a person, right? It could be a user, and we'll look at some other examples. Then I want you to notice that in pink we have systems. So the system doesn't have to be a microservice, but it could be also a logical component within our system. So within our service or application, it doesn't have to be necessarily separate applications. Then we can have things happening in parallel, right? So like we said, while we're announcing the redesign, then we're also starting the initial testing, and the content team is working on whatever. Then until finally the website is launched, we have a clear understanding of what's happening step by step up until the launch, where we have the engineers, everyone is there to share their opinion. And you can imagine if you try to do this over email, how this would go, or create a 1-pager or a 100-pager, how you would get everyone to agree and be on the same page. Now you can also see that some events are pivotal events, or these are events that are a bit more interesting. They probably have other events that are coming right after, and that the actor doesn't necessarily have to be a person, but it could be time, right? So we said we're doing this after 12 months at 12 p.m. Great, that's the actor that initiated that event. Then we don't need to go into detail, but what I do want you to notice is how we can get a shared understanding of specific key flows within our system. So from the search query was entered up until the search results were displayed. And in the background, we have some, search engine system that's computing search trends and notifying the recommendations algorithm, whatever, right? We can represent many things over here in an abstract, yet it's easy to understand, right? In a few minutes, we can explain the theory behind it. And also we can say, this is not that important as something else, right? We can look and say, some things are more important than others. Finally, there's the red and green sticky notes. So red sticky notes are for hotspots. So if these are branches that we don't want to explore, we have a misunderstanding, or we don't want to go too deep into it. We have a conflict on what we think it means, but we don't have the time to break it down. Then we put a hotspot. We say, let's get back to that. Then there are green sticky notes for opportunities. So tweet views is a new feature in Twitter from a few months ago. It's easy to see how once you have these events laid out, then you can say, whoops, this is a great feature that perhaps can be premium, right? Like tweet pinned and tweet unpinned. Let's make that for paying customers only, right? Why not? So this gives us the initial boundaries that we want within our system. So we're saying, ooh, I see, we have these swim lanes. Perhaps we can break it up something like the following, okay? Now, of course, this isn't final, and it'll probably change as we go along, but we can start seeing these relationships. Now, in domain-driven design, there are three types of subdomains. The first type is the core subdomain. Okay? So this is the moneymaker. This is what makes our business unique. and is what we want to spend most of our time, energy, engineering time on, because it's what makes our business make money, right? So social graph, this is obviously a core subdomain. So if we're thinking about why Mastodon and Blue Sky and whatever other apps aren't easily taking over Twitter, it's because they don't have the social graph. They don't have all the connections between the various users, who you muted, who you like, who you follow, right? All this data that Twitter has stored over the years. So social graph is a core subdomain, but you don't necessarily have only one. So also the tweet subdomain is probably a core subdomain as well, the timeline, right? Next, we have a supporting subdomain. So this isn't the core subdomain, this isn't the money maker, but it's important for our business, right? We want to spend some energy or effort on building it. And finally, a generic subdomain. So these are referred to as solved problems. So if we're thinking about messaging, there are many third parties that we can use for messaging. We can use something off the shelf. So if, for example, we fired the entire company, then we can just delegate messaging to a different company, right? But even if we define it as a generic subdomain now, we can in the future say, whoa, maybe let's send encrypted Dodge Bitcoin over DMs, and this will slowly become a more important subdomain within our system, and it'll move to a supporting, perhaps even a core subdomain as its value changes. Cool. Okay, so we have the various subdomains. We understand more or less how we can say, okay, this is more important, this is less important, based on the big picture event storming session. The next thing I want to talk about is context map. So, like we said, there are relationships between the various subdomains. So in domain-driven design, there's something called a context map. This is for visually representing relationships between various subdomains. So over here, we can see, right, the integration between the two. And there are various terms that compose the legend of the context of a context map. So over here, we can see, let's imagine we're talking about the flow. Let's say the recommendation subdomain is responsible for giving you recommended people to follow. So in Twitter, when you go to someone's profile and you follow them, sometimes you have a list of a few other suggestions of people you may want to follow. So let's say that's the responsibility of the recommendation subdomain. The social graph affects the recommendation subdomain. So in this relationship, or in this scenario that we're talking about, the social graph is the upstream, and the recommendations is the downstream. And there are various other terms. So let's imagine that because the social graph is such a crucial part of our system, then instead of it having a coupled relationship with various other subdomains, instead it has a well-defined API that each one of the clients can fetch data about the relationship of users with other users. And it's well-defined. This is a open host service that they expose. So you can imagine it's just like a well-defined API. And the recommendation subdomain uses the social graph to understand the relationships. And because it doesn't want the internal models to be the same as the data as the same way it comes off the wire, then it introduces some anti-corruption layer where it takes the data from the form that it came over the wire and converts it to the internal language that it speaks internally within the system, okay? That's an anti-corruption layer. How do we do this, right? So we have the various relationships, but how can we have the various subdomains, for example, or the initial understanding of what the various subdomains need to be. But how do we find all the various relationships? Process modeling, event storming. So process modeling, event storming is funner, in my opinion. In process modeling, event storming, you can see that we have 3 new types of sticky notes. So a command, a policy, and a read model. And like we said over here, we want to choose a specific frame to model. So let's look at an example. So over here, this is the frame that we're working with. The line on the left, it's the same side. The line on the left has a command. This is the command that starts the process that we want to model. So we can imagine this like create tweet, right? Something in past tense that is invoked by some actor. So we have the create tweet, and let's say, and that's on the left side. On the right side, we have domain events. These are the final events that happen, and we want to somehow connect these two sides. So let's imagine that we're talking about the flow where we create a tweet, and this tweet is talking about cars, for example, And you, as a Twitter user, then when you signed up, you said, I'm very interested in cars, right? You can choose cars, technology, you can choose these various topics that you want to follow. And you choose cars. How do we have this tweet somehow that doesn't have hashtag cars in it, but it is talking about something that's relevant for this topic? How do we have the subscribers of that topic notified about this tweet? Okay, so how can we model that flow? Now, what makes this interesting, and it's a game, where I see it as a game, is there are specific rules for the order of the sticky notes. Here it is. So we have, on the leftmost, we have the read model. The read model is, okay, we want to create a tweet, right? So the read model over here is the data that's needed to handle the command. So you can imagine it, if you want, from a UI point of view. It's the create tweet UI, and you click send, whatever. But what it actually contains is the data. So it's the text of the tweet. It's the media, perhaps, if you attached any media. It's the metadata, right? So sent from Earth or whatever other metadata that is passed with a request. Now, the actor, the user, right? So they observe the whatever UI, and they decide to invoke a command. The command is create tweet, and a command is always invoked on a system. The system, let's say, is the tweet system, right? Which corresponds to the tweet subdomain, but it doesn't necessarily have to. Like we said, the system is a logical component, not a application. So we decide to invoke the create tweet command. It's invoked on the tweet system, and then after that, we have either end, like or end. So the read model that returns back to the user, these are the details displayed back. So once you send a tweet, then whoop, you see the tweet back on your feed, right? You could also have it implemented so that the person who sent the tweet also gets an email that says, this is the tweet that you just sent, right? So multiple read models. Or a policy. The definition of a policy is loose, so it's what we do when this happens, right? What's the policy inside our system? When this happens, what do we do? So let's say we have a policy that every time a new tweet is created, we have a policy that we want to scan the text and see if there are various topics tagged inside, right? So let's say it talks about cars. Whoop, now we can tag this tweet with some internal metadata that says this talks about cars. Now what's nice about this is that we arrived here at the blue. After blue, whoop, we're back over here. We need to have a system, right? And from the read model, so now this can be observed by an actor, and we go through the same process, right? So we need to follow these rules. So here's just a simple example. So it's what we gave. We have some events on the left for context. The user registered, the user logged in. Then we have the user observing the read model and creating the tweet. So what it actually contains, again, is the data that's needed to handle this command. So we do, we invoke the create tweet command. It's invoked on the tweet system, like we said. This creates the tweet created domain event. Then we have the tweet created policy that scans the tweet for topics, okay? Now, a command is always invoked on a system. So let's say this is happening in some machine learning system. And then because this is a scenario that we want to model, of course, we can have multiple events where it's different branches, but this is the specific scenario that we want to cover, and also just for simplicity reasons for this talk. So the tweet tag topics, right? When I say tweet tag topics, we're saying in past tense that, yes, this tweet is talking about specific topics. So we tag topics, and we have a policy that every time that a tweet contains topics, then we want to update the topic, okay? Let's say this is managed by the recommendations system. It makes sense the recommendations is responsible for when you want to follow technology and cars, whatever. So it knows how to say, whoops, this tweet is actually talks about cars and is getting a lot of heat. Great, let's surface it, right? So this is handled by the recommendation system. And then every time a topic is updated, right, so we update it, then we have another policy that updates the subscribers, right? Fair enough. We could be modeled differently, of course, but this is what I chose. And let's say the subscribers are notified via email. So here we have the email system, and finally they're notified, okay? Now you can see how we modeled it from the left to the right. It follows only the rules that we talked about. And we're sitting here in the room 20 minutes into the talk, and we understand what we're talking about, right? It's not a very complex example, but it's also not very simple, right? How would we talk about it otherwise? It would be a bit more would be a bit harder. Also, over here, we can say, whoop, this is a good opportunity. Let's put a green sticky note over here. Let's make some money somehow. Also, once you're familiar with process modeling, then you could look at any process that was modeled using process modeling. And because we're already familiar with the sticky notes, great. This is what's happening over there. It's easy to understand what's going on. Okay? So we're looking at the process modeling that we did for key scenarios in our system, and we can start noticing relationships. So we can say, okay, wait, the tweet system has a relationship with the machine learning system, right? The machine learning system has a relationship with the recommendation system. Now, like we said, a system isn't an application or a microservice. We can have the machine learning system and the recommendation system sit inside the same subdomain. So, for example, let's say the machine learning system is part of the recommendation subdomain. It's just a logical component. So now we see, we have between the tweet and the recommendations subdomains, we have a specific relationship. Okay, we did that. We should be able, and I want you to imagine whatever other application that you're building or you want to build in the future, and we can see how we can take the big problem, do big picture event storming, find the boundaries, then do process modeling, find the relationships that we have between them. Of course, I'm talking about it like it's super simple, but every domain has its specific difficulties. And as you go along, then you change it. You say, no, this doesn't make sense. I don't know what I was thinking yesterday. Let's change it. Let's do something else. Okay, we have this. Now we can see, okay, these are the relationships that we have between the various subdomains. I put here a legend with all the various terms that exist in a context map. But you won't actually create one God context map to rule them all, because just imagine we're adding another subdomain, right? What would happen? Or this is hard to maintain. Also, it's inaccurate. So in specific scenarios, you might have two subdomains where this is the upstream and this is the downstream. In another scenario, it could be flipped, right? So you wouldn't actually create such a big context map. What you would do is you would create a specific context map for a specific case that you want to model. So let's say we're looking at the flow in which I have my home timeline in Twitter, and I just muted someone because I had enough. So I muted them. Now it should affect my home timeline, right? But how? So here's just a simple example, right? So the social graph affects the timeline. The recommendations also need to know. The recommendations subdomain needs to know to update the recommendations based on the person that I just muted. And then the timeline is also affected by this as well. Just a small example. Now, as you can see, we're starting to create a shared language for the various terms, right? So we're talking about the home timeline, I don't know, connections that we have between users, right? We're starting to create a shared language. And this is a very important concept in domain-driven design, where we want to use the same terms among everyone. So when I say terms, when I'm talking about the code base, I'm talking about the domain models, the actual objects that we have in our code base. And when I say terms in the context of product managers, then we want it to be the same thing. So how does domain-driven design deal with the following problem? In the recommendations subdomain, we can imagine that we have a recommended user, right? Someone that, like we said, we want to recommend a user for you to follow. So it could be called recommended user, recommended profile, whatever we choose. But let's imagine that we just decided to call it recommended user. Then in the timeline, we have the user. So this is the user that, let's say, is making the request. And in the social graph, it's all about users, right? So we have there a user. How does domain-driven design deal with having the same term in multiple subdomains, right? We can imagine that in many of the subdomains, we'll have a user. How can we stay consistent when each one of the subdomains has the exact same term? So who thinks they know how domain-driven design deals with this? Raise your hand. Or who thinks they can guess what it is? Okay, so I'll choose one. Elon. I was just about to choose someone from the crowd to give the answer. Do you want to go? He wants to tweet about it. So wait, let's see what he says. Bounded context. So that's the correct answer. Thank you, Elon. Thank you very much. So bounded context is the correct answer. That's how domain-driven design deals with this problem. So a bounded context is a logical boundary in which the terms are consistent. So it's not a problem that the user term or domain model exists in various subdomains, because we just map each one of the subdomains to a different bounded context. Okay, so ideally, each one of the subdomains is its own bounded context. If we imagine it from a microservice point of view, then we might have the recommendations microservice, and it has a team that's working on that. They have their specific language that they use internally. Perfect, right? And when they say user, they know exactly what user means. Okay, and same thing for the social graph and the timeline. Okay, by Elon. So that's how domain-driven design deals with it. Now, I think he has another one. Ubiquitous language. I almost forgot. So thanks, Elon. So ubiquitous language, the language used within a bounded context is referred to as its ubiquitous language. This is one of the core principles in domain-driven design, because we want to make sure that everyone's aligned on the terms that we're using. So like we said, we want the models and the code to be the same as what the sales are talking about when they're talking to customers. So you can imagine how many problems this solves when everyone's speaking the same language, okay? So the language used in a bounded context is the ubiquitous language. Okay, so that was strategic design. Again, we want to take a big domain, break it up into smaller subdomains. Now the question is, how do we take these subdomains and we break them up further? Okay, so the second stage is tactical design. Now we want to zoom in on each one of the subdomains and break it up in a way that we can say, okay, this is the logical representation. I can take that and turn it into working code, right? I can take that and I know what code I want to write. So that's tactical design. Luckily, we have this fake thread. I forgot to say, all the tweets are fake, right? I just want to make a disclaimer that I forgot about. All the tweets, other than the first tweet, are fake. So this is a fake thread by Eric Evans. And here we have a list. It's just for engagement reasons. I don't know, I thought it'll be nicer to watch it, to see it this way. So we have Eric Evans with a fake thread about the various tactical patterns that exist. So tactical patterns are the building blocks in which we can break up the subdomain. And when we have the process of breaking up the subdomain into smaller components that we can afterwards convert to working code, that is the process of tactical design. Okay, so tactical patterns, the building blocks, tactical design, the process. The first one is entities and value objects. Raise your hand if you're familiar with entities and value objects in domain-driven design. Okay, great. So just so everyone's up to speed. So this is when my wife walked in to the room and saw me doing this, and I was working on the animation of the neon, and she told me, "You're going overboard." I was like, you know how weird it would look if he wasn't holding two neon lights in his hands? Okay, so we have entities and value objects. Okay, these are the two. So if we look at any domain that's built following domain-driven design, so before I said domain, I was talking about the entire Twitter domain. And when I said subdomains, I was talking about each one of the subdomains. Now when I'm saying domain, I'm just talking about each one of the subdomains, okay? So if you look at any domain that's built following domain-driven design, any object you look at, any domain model that you look at, falls into the bucket of either being an entity or a value object. Now this is pretty simple. So an entity, all it is an object that has an ID. So over here we have two people. Both have the same ID, 1, 2, 3, 4. And what's interesting about entities is that they're considered the same even if the values are completely different. So if I change my favorite color from blue to green, I'm still the same person, right? So this is something that we probably want to model as an entity, right? So we can change properties inside, stays the same person. On the other hand, if we would model it as a value object, then these would be considered different domain models, because value objects, as the name suggests, is all about values. A value object doesn't have an ID. It can have a property that's called ID with some value, but it's just another property within the... So even if we did have here the ID property on the person, these would still be the exact same object. And these would still be different objects. So let's focus specifically on the timeline subdomain. I think it's the most interesting, plus it has some good examples. So let's say the responsibility of the timeline subdomain So now we're going to do tactical design for the timeline subdomain. So let's imagine the responsibility of the timeline subdomain is three things. One, the profile timeline. So this is just when you go to someone's profile, you see their tweets in reverse chronological order. The second responsibility is the home timeline. So this is where you see a mix of tweets from people you follow and random recommendations from the recommendation algorithm. And lastly, the list timeline. So who's familiar with the feature of lists in Twitter? Yes, so the feature of lists in Twitter allows you to create a list of multiple members. And it works like this. This is the focus for the next subsection. So let's say I create a list of highly influential individuals where it contains 2 members. So we have Barack Obama and myself. It's a good subset of individuals. And every time one of us tweets, then it should appear over here in reverse chronological order. So it's like merging the profile timeline of multiple people. All right, so he tweeted about something, it's added. Then I tweet about something, it's added. Great. We can also add new members to the list, right? So we can say now we want to also add Elon Musk, of course, very influential. So rip, added. One of his tweets was between hours, so it goes somewhere in the middle. And of course, we can add followers, etc. So we have a shared vocabulary. Let's call the entire thing a list timeline. We'll call the tweets in reverse chronological order the timeline. We'll call each one of the entries inside a timeline entry. And inside we'll have a tweet. Let's say we have this wrapper because we also want to put tweet ads or whatever, right? So we can differentiate between the various types. So let's see if you were listening. Welcome to the game show, entity or value object. So the tweet. Now we're modeling our domain.
Here's what I found.
Should the tweet be modeled as an entity or a value object? Who thinks entity? Raise your hand. Okay, who thinks value object? Raise your hand. Okay, so we should probably model the tweet as an entity. Why? Because if we have the exact same tweet, we still want to treat it as different tweets and not the same tweet, right? So same values doesn't mean same tweet. Another example, we have the entire list timeline. Should this be modeled as an entity or a value object? Who thinks entity? Who thinks value object? Okay, so tie. This should also be modeled as an entity. Why? Because this is a list that, as we can all expect, is going to blow up once after this talk. I'm sure it's going to go to the hundreds of thousands of followers. So if we have 2 list timelines, and it's with the same ID, but because of some race condition, one has 0 followers, the other one has 1. If we're looking at them in memory, we're still talking about the exact same list, right? It's not different lists just because one of the values inside is different. Okay, of course, we can also add members, the tweets. One can contain a new tweet. So this should probably also be modeled as an entity. All right, this brings us to aggregates. So entities and value objects, great. Those are the 2 most basic building blocks in tactical design. The next thing is aggregates. So for this, let's understand the problem. So we have, again, the list timeline. And in some point in time, Eric Evans, the one who coined the term domain-driven design, comes to us and said, this is what the list looks like. So we have 3 members, me, Barack Obama, and Elon Musk. We want to add Elon Musk again. Should we allow it? No, right? Because he's already part of the list, so we probably shouldn't allow it again. But that's just one example. We'll probably have many permutations, especially in such a highly requested list of subset of people. So we'll have many permutations in many different points in time. Another question is, how do we make sure that it's always in a consistent state? So the definition of an aggregate is one or more domain models that always need to stay consistent as a whole. So we have, for example, the list timeline aggregate. It's the responsibility of the list timeline aggregate to make sure that the list timeline is always in a valid state, not adding the same member twice, not adding the same follower twice, not having the same tweet twice inside, right? All these various constraints and variants that we want to enforce. What's important to say about aggregates is that in the database, So it's also a consistency boundary. It's, like we said, it needs to stay consistent as a whole, but it's also a consistent and a transactional boundary, meaning that when we write it to the database, we want to write the entire aggregate as a whole. So if we imagine the data sitting somewhere in the database, right, let's say a relational database, then we write it to the database, we replace everything that was there before, and we also, when we read it, if we read it in order to change it and write it back, then we read the entire thing, make changes, write it back as a whole. And what's important is that within the database, we won't have any foreign keys or any relationships between this aggregate to other records or rows or columns in the database. Because we don't want another aggregate to have changes, and then it'll suddenly affect our database behind the scenes, right? Because we affected our line somehow. Okay, so that's something very important to notice and sometimes is overlooked. And this makes sense, right? So now we have this atomic unit that we know is always in a valid state because we write it to the database. No one's touching it other than us. We read it as a whole. We make changes, whatever. All right, so great. The entity that is the root of the aggregate, so each one of the aggregates has an entity root, right? So which is the root of the entire entity. So it's called the aggregate root. So in this case, the list timeline aggregate or entity is not just an entity, but it's also the aggregate root, and the aggregate is that entity with everything contained inside recursively. Then there are a few other tactical patterns like services for common logic, repositories for fetching aggregates from the database, factories for creating complex objects and modules, which isn't shown over here, but we'll see when we talk about the folder structure where this comes into play. So we have the timeline subdomain, and we did process modeling for key processes in our system, and we came up with all these various entities, right? So we have the timeline, the list timeline, and many, many others, right? We can imagine also, let's say we have the advertisement and other things that aren't shown over here. We have many. Now the question is, how do we break it up following into the various tactical patterns in a way that makes sense? So like we said, how do we decide which one is an aggregate and which entities over here are contained within the aggregates? How do we build this in a way where we have atomic units that make sense with one another? So instead of giving the answer, let's look at an example. This is another game show. It's called Yay or Nay. So because it's really hard for me to see, then we'll change the format. Instead of just saying, raising your hand, you can raise your hand and say yay, or raise your hand and say nay, okay? So let's go over this example, and in the end, we'll ask ourselves yay or nay. So here's just the data visualized in JSON, okay? So it's a language agnostic, but you can imagine the object behind the scenes in whatever language that you're programming. So what we have is the following. So we have the name, then we have the author of the list, and the details, so the ID. This over here is an entity that's contained inside the aggregate. And we have the name, the photo, the handle, whatever. Next, we have the list of the members. So over here, this contains the member entity inside, right? The list timeline aggregate contains the member entity inside, or a list of member entities. And we have them underneath. We see we have followers. So if we had 1,000 followers, then they would sit one underneath each other. And for the timeline, so we have the timeline, then the entries, and then each one of the entries. So we have over here the timeline entry entity that has the ID of 1, the type is tweet, and then it has the tweet entity contained inside that entity, where it has some ID, then it has the author of the tweet, the content, the media, the interactions, the tags that we talked about before. Perhaps it's also part of that, right? Great. And the same thing for the other one. Yay or nay? Who thinks yay? Raise your hand and say yay. Okay. Who thinks nay? Raise your hand and say nay. Nay, great, okay. So most of you said nay, and nay is the correct answer. And of course, this is something we want to avoid, okay? So this is like a one God aggregate to rule them all. And this is something we want to avoid. Why? Because you can imagine the latency that we'll have when we need to pass all this data over the wire every time we want to make a change, right? We don't want to do that. We don't want the bird to sweat. Also, the throughput, right, it'll cost us more. And it raises a chance that we'll have race conditions. So we have two followers following at the exact same time. Like we said, many people are going to follow this specific subset of individuals. We have two followers coming at the same time. Now we read the entire thing. We made that change. Now we have a race condition. We'll need to fail one of the requests, right? Problematic, we don't want that. And also, when someone follows this list, we don't want to have to load from the database old tweets. I mean, who cares, right? It's not part of it. So that's not good. What we actually want to do is we want as smaller aggregates as possible, right? This makes sense. We want smaller atomic units that have no effect on one another. When we make changes to them, then it doesn't change anything else, and we know we're safe. Let's do another round of yay or nay. So here we have each one of the aggregates defined as small as possible. So here we have the list timeline defined as an aggregate, and here it has all the minimum amount of data that it needs. So the name, then the ID of the author, and the author itself is also an aggregate root now. So before it was an entity, now it's not only an entity, but it's an aggregate root. And we're holding only the ID of that entity within the list timeline aggregate. And same goes for the rest. So for the entry IDs, for example, I put here what it would look like. So we have the entry aggregate that also has an ID. It's now the aggregate root, right? And inside it contains the list ID that it belongs to, right? Because we still need some correlation between them. It has the tweet ID, which is also an aggregate. And that's it. Who thinks yay? Raise your hand and say, yay. Okay, I hear some more yays. Who thinks nay? Raise your hand and say, yeah, nay. 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 So the correct answer is nay. Why nay? Who thinks they know the answer and wants to? Yes, Elon. He's going to tweet about it. So I'll add him to the members. Let's see what he says. Invariance. Okay, so invariance is the correct answer. Like we said, we want to make sure that the list timeline aggregate is always in a valid state. We can't enforce that if we're looking at the entry IDs, for example. So we can enforce, for example, that the same member isn't twice in the list, because we could just check the ID, right? The ID for each user is unique. Great. The ID is not in the list. Perfect. But if we have two completely different lists where Elon Musk is a member in both of them, then we'll have two separate entries with two different IDs that both contain the underlying same tweet ID. The list timeline aggregate can't enforce the invariant of having the same entry ID twice. It can't make sure that that doesn't happen because it doesn't have enough data over here, right? So this isn't good. What we would actually want to do is we would want to merge the timeline entry into the timeline aggregate so it's contained inside, like so. Okay, so now it no longer needs the list timeline ID because it's already part of it, so it doesn't need that for correlation. And now we can enforce, right? It has a tweet ID. It's here twice, the same tweet. Can make sure that this never happens. So modeling a domain layer is not an easy problem, and I always go back and forth with many different like combinations or permutations. But here's my opinionated step-by-step, because it really isn't a step-by-step today. So the first stage is, like we said, process modeling. We have all the various entities, the value objects. We know what we're facing. Then we want to see the relationships that they have with one another. So we have a one-to-many relationship between the list timeline and the list entry, right? Because we know we have many list timeline entries within one list timeline. So we have all this mapped out. Now what we want is we want to define each one of the entities as an aggregate. Okay, so a value object is always part of some entity. So first thing we want to do is let's have each one of them as the smallest atomic unit possible. Okay, we did that, but it doesn't always work like we saw before. So the next step is to merge aggregates when there are constraints. So one of the constraints that we already looked at is that we need to enforce the invariance, right? So the first one is invariance. We need to enforce something. It doesn't make sense without it. So if we have a dinner and reservations, it makes sense that the reservations can't be an aggregate. We need to fold it into the dinner aggregate so it can make sure that there isn't more guests than the maximum allows. And the next type is eventual consistency. So, like we said, these are atomic units in the database, in our system. Changes across aggregate are only eventual consistent. So if we add a new member to the list, so over here we have a member that isn't part of the list, right? So we'll create the member, then we'll have some member-created domain event, right? We looked at domain events before. This is already going back to the process modeling. So once you're familiar with this, during process modeling, you can already imagine what the code, the underlying code will look like. So we have the member-created domain event. Then there'll be some handler listening to this event. We'll fetch the aggregate from the database, add the member to the list, and of course, less chance of race condition because everything is much smaller, everything is faster. And worst case, we have a race condition, great, we'll handle that request again, and then we can add them, right? But it's only eventual consistent. So sometimes we can't tolerate the eventual consistency, so we don't have a choice but to fold them inside. So if we can't tolerate the eventual consistency, that's another constraint, and we merge them together. So what we did in tactical design is taking the domain, each one of the domains, breaking them up into aggregates, which internally are entities and value objects. And we didn't talk about services, repositories, and factories much, but we will see in the folder structure in a minute where it comes into play. Okay, so we did strategic design. Like we said, this breaks it up into smaller subdomains. Then we did tactical design, where we broke up each one of the subdomains. We looked specifically at the timeline subdomain, but as you can imagine, each one of the other subdomains will have its own entities, its own terminology and terms, whatever. So in the advertising subdomain, we can imagine that we'll have terms or domain models such as campaign, sponsored trend, things like that. So even though we didn't go into each one of them, I do want you to have the tools to imagine what this would look like if you would go down the road of implementing what we talked about today. Okay, clean architecture. On time. So clean architecture, we have each one of our domains, right? These are web services, let's say, and they need to have interactions with one another. How do we actually implement this in a way where it's both testable? We want to create a system that will thrive in the long run, right? I mean, Elon asked, he's expecting from us, so we want to do that. So the domain layer, all we talked about the aggregates up until now. We can imagine we modeled them, we have the domain models, the basic C#, Java, TypeScript, whatever objects that you have, they sit in the domain layer. So in the domain layer, we have the aggregates. This doesn't have to be a project, it can also be like a folder, whatever. It's a logical boundary. It should, in the end, I'll talk about it maybe. Okay, so we have the aggregates inside the domain layer. Then we have the presentation layer. The presentation layer is how we speak with the outside world. So in our case, because we're building a web service, let's imagine that we're using ASP.NET or REST and JSON. So that's where we'll have the controllers for interacting with the outer world, like we talked about before with the anti-corruption layer. So the responsibility of the presentation is to take the request as it comes off the wire and convert it to the internal language that we speak within our system. Okay, now the motivation behind this is that currently we're using REST and JSON, but we were in a great talk this morning about gRPC, and we want to replace it with gRPC. So we should have the flexibility to change the underlying technology or framework that we're using, so that all we need to change is the conversion from however the data comes off the wire to the internal language of our application. Okay, now this is just because we're building services, but this could also be the UI, right? The presentation layer is the door to the outside world. Now, after we converted the data off the wire to our internal language, then we call something in the application layer. The application layer is where we have our use cases, and the application layer is basically responsible for orchestrating the aggregates. So we have the various aggregates. Someone needs to call, if we're adding a timeline entry to the timeline list aggregate, someone needs to call the add method, right? Application layer. Now, the beauty about clean architecture is that the inner layers define interfaces. So the application layer can define various interfaces, and outer layers have the implementation for those interfaces. So in the infrastructure layer, we would have all the various infrastructure concerns, like the database, the authentication logic, perhaps. We're talking to various other services, so the web clients. Since the interface definition sits in the inner layers, in the application and the domain layers, we're able to switch the concrete implementation without caring about it from the inner layers. So let's look at an actual example. Like we said, we want to see how we can convert this to working code, what the folders and files will look like. So in the presentation layer, again, let's imagine we're using REST and JSON. So we have the actual list timeline controller. We're looking at the flow of fetching a list timeline, right? So now we're going to a list on Twitter. We want to see the list timeline. So this is how the folder structure for that can look, or what I'm presenting. So we have the list timeline controller that has the get endpoint, whatever. Then we took all the various, the API definition, we put it in a contracts folder because we want to be able to publish it as a NuGet package or NPM package, whatever, have other clients consume it. Like we said, the services are talking to one another, so it makes sense that we want to have it defined in one place, versioned, so clients can consume it instead of having to rewrite the models again. And the list timeline controller invokes the appropriate logic in the application layer. So here it's split following CQRS, but if you're not familiar with CQRS, then you can imagine it like a get list timeline method in a timeline service or whatever, something like that. It's just the actual piece of logic. Then to fetch it from the database, then the handler over here, what it does is it uses some interface. This is just a plain interface that has some get method, right? That whatever the implementation is, knows how to fetch it from the database. So from the application point of view, it's simply using this interface. The concrete instance can change. It doesn't care from its point of view. Then in the infrastructure layer, we have the actual implementation of the repository. So here we see the DB context, so we know, okay, it's EF core, but it can be whatever we want, right? And if we want to mock it for unit testing, then we can. If we want to put a in-memory DB, whatever, we can do whatever we want because it's just a plain old interface that's great for testing. And we can change also in the infrastructure layer. So we want to switch to whatever, a different database happens every day, right? So we have the flexibility to do that. And of course, some changes will have to leak into the application layer. So we'll have to change the interface in the application layer, but it still gives us the loose coupling between them. Finally, the domain layer. So here we have the actual aggregate. In the way I'm presenting it, and I would suggest as well, each one of the list timelines, or each one of the aggregates gets its own folder, and inside it has the entities and value objects that are part of this aggregate. So the list timeline is also an entity. It's just a special entity. It's also the aggregate root. And I want you to notice the events folder. So over there we have all the events that occur. Like we said, something happens in our system. We raise some event. Handlers listen to this event and make changes to other aggregates appropriately. Okay, so we talked about strategic design, big picture, context map, right, subdomains, etc. Tactical design, breaking it up further. And finally, clean architecture with the various layers. I put over here 3 links. So one of them is for this presentation. So if you want to zoom in on the various details, then you can zoom in. Event storming, so everything we saw in this session about event storming was created in a free online tool that I created for event storming. I think it's the best tool available for online event storming, but of course I'm very objective. And it's free, it's private, it's a Figma community file, so it's very collaborative. You can have hundreds of people working at the same time. And finally, if you enjoyed this and you want to see more of this, then there's the rightmost QR code. So that's it. Thank you.